A single drop of water could ruin weeks of work. Yet medieval hat makers created perfectly shaped felt hats using techniques that seemed to defy the properties of the material itself. How did these craftsmen transform rough animal fur into smooth, waterproof hats that held their shape for decades, all without the steam-powered equipment that modern hatters consider essential? Medieval hat making wasn't just about keeping heads warm, it was about status, identity, and the mysterious alchemy of transforming loose animal fur into felt so dense it could turn a sword blade. A merchant's beaver hat announced his wealth as clearly as his manor house, while a peasant's rough wool cap marked his place in society's hierarchy. But creating any felt hat, from the finest beaver to the coarsest wool, required mastering techniques that pushed medieval craftsmanship into realms that seemed almost magical to those who witnessed the transformation. The medieval hat maker's workshop stood apart from other craft spaces, recognizable by the distinctive smell of wet wool, the rows of wooden hat forms in every conceivable shape, and the mysterious felting tables where loose fur somehow became solid fabric, through processes that most people couldn't begin to understand. These workshops weren't large or imposing, but they contained some of the most specialized equipment and techniques in medieval craftsmanship. Tools and methods that had been refined over generations to achieve results that seemed impossible. Inside these workshops, the air was thick with fiber particles that caught the light streaming through carefully positioned windows. Unlike other crafts that required consistent lighting, hat making demanded specific types of illumination that would reveal the subtle color variations and fiber quality that determined whether a hat would be serviceable or exceptional. Master hatters arranged their workshops around these lighting requirements, positioning work areas to capture the exact conditions needed for different stages of the complex felting process. The most mysterious aspect of medieval hat making was the felting process itself, a transformation that turned individual animal fibers into cohesive fabric through techniques that combined chemistry, physics, and accumulated craft knowledge in ways that wouldn't be scientifically understood for centuries. Medieval hatters achieved this transformation without steam, without modern chemicals, using only hot water, soap, and manipulation techniques that had been perfected through generations of trial and error. The Guild of Hatters maintained control over felt production through regulations that were more complex than those governing most other medieval crafts. The quality of felt determined not just the durability and appearance of finished hats, but their social significance and economic value. Poor felt would fail within months, while excellent felt could last for decades while maintaining its shape and protective qualities. Guild standards addressed every aspect of production from fiber selection to final finishing, creating a framework that ensured consistent quality while protecting trade secrets. Apprenticeship in hat making required learning skills that combined manual dexterity with scientific observation, though the science wasn't understood in modern terms. Apprentices had to develop sensitivity to fiber quality that allowed them to judge wool and fur by touch, learn to control the felting process through subtle manipulation of temperature, moisture, and pressure, and master the shaping techniques that transformed flat felt into three-dimensional hat forms. Master hatters guarded their most effective techniques jealously, passing knowledge only to apprentices who had proven both competent and trustworthy. These trade secrets included the specific soap formulations that promoted optimal felting, the manipulation techniques that created the densest felt with the least waste, and the finishing methods that gave completed hats their distinctive appearance and weather resistance. Guild bylaws imposed severe penalties for sharing these secrets with non-members, protecting the competitive advantages that allowed established hatters to maintain their market positions. The selection and preparation of raw materials for hat making required expertise that combined animal husbandry knowledge with understanding of fiber properties that determined the quality of finished products. Not every animal fur was suitable for felting, and even good materials could be ruined by improper storage or preparation. Master hatters developed relationships with trappers, farmers, and fur traders that gave them access to the highest quality materials while ensuring consistent supplies throughout the production season. Beaver fur represented the pinnacle of hat-making materials, prized for its density, water resistance, and the exceptional felt it produced when properly processed. But beaver fur was expensive and often difficult to obtain, requiring hatters to develop techniques that maximized the value extracted from every pelt. The preparation of beaver fur involved removing the long guard hairs that wouldn't felt properly, then carefully cleaning and sorting the remaining undercoat according to quality grades that determined its use in different parts of finished hats. Wool, more readily available but more challenging to work with, required different preparation techniques that removed oils and impurities that would interfere with felting while preserving the fiber structure needed for successful transformation into felt. Master hatters understood which breeds of sheep produced the best wool for different types of hats, how seasonal variations affected wool quality, and the processing methods that would optimize each batch of material for specific end products. The most critical aspect of material preparation was achieving the proper moisture content and temperature that would promote felting without damaging the fibers. Too much moisture and the fibers wouldn't bond properly, too little, and the felting process would be incomplete. The water used for preparation had to be heated to precise temperatures, using methods that provided consistent heat without overheating that could ruin entire batches of valuable material. The actual felting process required techniques that manipulated the microscopic structure of animal fibers in ways that medieval craftsmen understood empirically, without knowing the scientific principles involved. Animal fibers have scales that interlock when subjected to heat, moisture, and agitation in specific combinations, creating the cohesive fabric we know as felt. Medieval hatters achieved this transformation through carefully controlled processes that combined these elements in proportions they had learned through generations of experience. The initial stage of felting involved creating what hatters called the bat, a loose mat of prepared fibers arranged in layers that would eventually become solid felt. The orientation of these layers determined the strength and flexibility of the finished felt, requiring careful attention to fiber direction and density that would affect every aspect of the completed hat's performance. Master hatters could judge proper bat preparation by visual inspection, feeling the texture and watching how the fibers behaved when manipulated. Hot water application had to be controlled with precision that approached modern industrial standards, despite being achieved with medieval tools and methods. The water temperature, the amount applied, and the timing of application all affected the felting process in ways that could make the difference between success and failure. Too hot, and the fibers would be damaged. Too cool, and they wouldn't felt properly. Master hatters developed techniques for judging water temperature through tactile methods that were accurate enough to ensure consistent results. The manipulation of wet fibers during felting required physical techniques that combined strength with delicate touch, applying pressure and motion that would encourage fiber bonding without damaging the developing felt structure. This work was physically demanding and required skills that took years to develop, since improper manipulation could ruin hours of preparation work and waste valuable materials. The shaping of felt into hat forms represented one of the most challenging aspects of medieval hat making, requiring techniques that worked with the natural properties of felt to create three-dimensional shapes from flat material. Unlike modern hatters who use steam to make felt temporarily malleable, medieval craftsmen had to achieve shaping through manipulation of moisture, heat, and pressure applied in specific sequences that would permanently alter the felt structure. Wooden hat blocks, carved into the exact shapes desired for finished hats, served as forms around which felt could be shaped. But the process of conforming flat felt to these three-dimensional shapes required techniques that pushed the material to its limits, without causing it to tear or lose its structural integrity. Master hatters developed methods for gradually stretching and forming felt that took advantage of its unique properties while working within its limitations. The stretching process had to be done while the felt was at optimal moisture and temperature conditions that made it workable without being fragile. This required careful timing and environmental control that coordinated multiple factors to create brief windows when shaping work could be performed successfully. Experienced hatters could judge these conditions through tactile and visual cues that indicated when felt was ready for shaping operations. Heat application during shaping was achieved through methods that provided controlled warming without the steam equipment that modern hatters use. Heated blocks, carefully controlled fires, and even body heat were used in combination to maintain the temperatures needed for successful shaping, while avoiding overheating that could damage the felt or cause it to shrink unpredictably. The finishing techniques applied to shaped hats involved surface treatments that improved appearance, water resistance, and durability, while maintaining the structural integrity achieved during the felting and shaping processes. These treatments included brushing methods that raised or flattened the felt surface, waterproofing applications using materials that wouldn't interfere with the felt's breathability, and sizing treatments that helped maintain hat shape during use. Quality control in medieval hat making required evaluation methods that could detect subtle problems that might not become apparent until hats had been in use for extended periods. Master hatters developed testing procedures that subjected felt samples to conditions simulating years of use, allowing them to identify production problems before finishing entire batches of hats. These tests included exposure to moisture, heat, and physical stress that revealed whether the felting process had been successful. The economic structure of medieval hat production reflected the significant differences in materials and labor required for different quality levels. Simple wool caps could be produced relatively quickly using basic felting techniques and common materials, while luxury beaver hats required weeks of work, using expensive materials and the most advanced techniques available. This created market segments that served different social classes, while allowing successful hatters to build profitable businesses. The social significance of hats in medieval society created demand patterns that influenced every aspect of production planning and quality control. Hats weren't just functional items but symbols of social status, professional identity and regional affiliation that had to meet specific standards to serve their intended purposes. A merchant whose hat appeared cheap or poorly made could suffer business consequences, while inappropriate hat styles could result in social ostracism or legal penalties. The guild system that controlled hat production also established quality standards that ensured hats would perform their intended functions, while meeting the social expectations associated with different styles and price levels. These standards addressed technical aspects, like felt density and water resistance, but also aesthetic criteria that determined whether hats would be acceptable in different social contexts. Regional variations in hat styles reflected local preferences, available materials, and traditional techniques that had developed in different areas over centuries of hat making. These variations created specialized knowledge requirements that successful hatters had to master if they wanted to serve diverse markets, but they also created opportunities for craftsmen who could produce distinctive styles that commanded premium prices. The seasonal rhythms of hat production were driven by both material availability and demand patterns that varied throughout the year. Fur and wool quality varied seasonally, creating optimal periods for material acquisition and processing, while demand for different hat styles fluctuated with weather patterns and social events that required specific types of headwear. Weather conditions affected both production processes and finished product performance in ways that required constant attention and adjustment. Humidity levels influenced felting success, temperature variations affected material behavior, and precipitation patterns determined when certain types of work could be performed successfully. Master hatters learned to work with these natural variations rather than fighting them, adjusting their techniques to achieve consistent results despite changing conditions. The tools and equipment used in medieval hat making represented some of the most specialized implements in textile production, designed specifically for the unique requirements of felt production and hat shaping. These tools included brushes made from specific animal hairs that would achieve desired surface textures, shaping implements that could manipulate felt without damaging it, and measuring devices that ensured consistent hat dimensions despite the challenges of working with a material that could shrink or stretch unpredictably. The knowledge and techniques developed by medieval hatters established principles that influenced textile production and fashion for centuries. The empirical understanding of fiber behavior, felt properties, and shaping methods that these craftsmen achieved through careful observation and experimentation laid foundations for modern textile engineering and fashion design that continue to influence contemporary manufacturing methods. The guild system that controlled medieval hat making also created professional standards and quality control methods that evolved into modern manufacturing quality assurance systems. The emphasis on material selection, process control, and finished product evaluation that characterized the best hat-making operations established precedents for systematic quality management that remain relevant in modern manufacturing contexts. Understanding what tricks medieval hat makers used to shape felts without steam reveals a world where practical necessity drove remarkable innovations in materials processing and product design. These craftsmen developed solutions to complex engineering problems using empirical methods, creating production systems that served their communities, while establishing techniques that remained viable for centuries after their development. The precision and reliability of medieval felt production represented achievements that demonstrated sophisticated understanding of materials science and manufacturing processes. The hatters who perfected these techniques created products that served essential functions while meeting demanding social and economic requirements, establishing a legacy that extends far beyond the hats they produced. The next time you see a felt hat or handle felt fabric, remember the medieval hatters who first mastered the art of transforming loose animal fur into durable shaped textiles. They worked without steam equipment, without modern chemicals, without even thermometers to monitor their processes, yet they developed felting and shaping techniques so effective that many of their methods remained in use until industrial machinery replaced hand craftsmanship. Their legacy lives on, not just in the techniques they developed, but in the fundamental understanding that working with natural materials requires patience, observation, and deep respect for the properties that make transformation possible. If you enjoy the hidden sides of medieval life, hit subscribe and give this video a like.